Welcome to the fourth and final video on thin-walled pressure vessels for Monday, the 13th. For this one, we'll be doing a quick example where we'll consider a cylindrical pressure vessel and we'll find the stress at a particular angle according to its weld. Have fun. Let's say we have a tank, and it's a pressure tank. It's cylindrical in shape, and it's made by welding together a strip of steel at 20 degrees, like that. And we want to know what the pressure, and the pressure, let's say that is equal to 85 pounds per square inch, and we want to know what the normal stress is orthogonal to this weld. Well, in that case, we have a cylindrical tank, so for a cylindrical tank, we have a stress state that is like that, and we have our normal stress 1 and stress 2. And we say that stress 1 is equal to P times the radius divided by the thickness. I guess I should go to the thickness as well. Let's say the thickness is equal to 3/8 of an inch. So our stress, our hoop stress about the round bit of the cylinder is going to be 85 pounds per square inch times, that's 5 feet. I'm going to go ahead and swap into inches right now because, well, that's in inches. So 30 inches is what 2.5 feet is, divided by the thickness, which is 3/8 of an inch. That equals 6,800 psi. And the stress in the second direction along the length of the pipe, the longitudinal stress is, well, it's equal to half that, right? I guess we can write it out, but it's 85 psi, 30 inches divided by 2 times 3/8 of an inch, which is going to give us 3,400 psi. So now we move on to Moore's circle. Those of you who always hated that Moore's circle didn't start necessarily from the rotation didn't start from the x-axis will be delighted with this topic, I'm sure. because we're going to start right here is going to be 6,800, 0. And right here is going to be 3,400, 0. And so we're going to need to rotate this cube 20 degrees this way, right? Because of how that weld is. So, well, let's also mark the average. The average is going to be 1.5 times 3,400. So that's going to be 5,100. And then 0. So we've got that, and then the radius, right? The radius is equal to 1/2 times normal stress in the longitudinal direction, and that's going to be 1,700 psi. So we have a point up here, which is going to be 5,100 and 1,700. So we're going to rotate this. We remember have to rotate twice as far as we would normally want to, right? Because we're in more circle space. So I want to about get it right. So now we've moved, and we're in this spot right here. So we want to know about these points, obviously. So, and then this angle right here is 2 times 20 degrees, 40 degrees. So let's break this down into, let's just look at this triangle. Triangle, 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 triangle. Okay. Out this triangle. We know that this right here is the radius. We know the radius is 1,700 psi. There we go. There's an I there. We know that this is 40 degrees, which means that we know that this is r times the cosine of 40 degrees, and then this is the shear stress at our new point, which is equal to r times the sine of 40 degrees, which means that our new shear stress is going to be, yeah, red's a good color for that, 1,700 psi times the sine of 40 degrees, which will equal 1,092.7 psi. So And then we're going to have a normal stress 1, which goes right here, and normal stress 2, which goes with this one. Normal stress 1 is going to equal the average normal stress, plus the radius times the cosine of 40 degrees, and that's going to equal 5100 psi plus 1700 psi times cosine of 40 degrees, and that's going to equal 64.02.3 psi. And the normal stress in the second direction is going to be the average stress minus, because that triangle is the same as that triangle, r times the cosine of 40 degrees, which is going to be 5100 psi minus 1700 psi times the cosine of 40 degrees, and that's going to be equal to 3080 just about. 3797. 3800 basically, 0.7 psi. And be careful when you look at this, determining which one is which, right? Is it this orthogonal to the weld, or is this orthogonal to the weld? Well, the longitudinal stress, the one that was just down here, was almost orthogonal to the weld. So this is the one that went from here to here with our 20 degree rotation, is the one that became orthogonal to the weld. So, orthogonal to the weld, we're only going to be seeing 3,798 psi, as opposed to along the weld. Along the weld, we'll be seeing this this 6,400 that is represented by this point right here. So be careful about that, because obviously that's a pretty massive difference. Okay, well, I assume most of you stopped listening because it's just more circle and you've done that before. Have a safe Easter weekend.